So, very good morning to all. So, we will continue to do the problem in today's lecture. So, the today's lecture learning outcomes are using a ray diagram, kinematic diagram, both ray and kinematic diagrams, to calculate number of gear teeth on each gear in the gearbox. So, we are going to learn about how to calculate number of teeth using both ray as well as kinematic diagram, and this is the problem. So, as you are aware of, we have a 12 speed gearbox, okay. This and minimum speed is given and maximum speed given, and this was the structural formula we have used. So, initially what we did, we completed the ray diagram aspect, then constructed kinematic diagram. Now, the third part what we are going to do is to calculate a number of teeth on each gear. That is what we are going to do that. Right. Assumption. So, in the problem statement, right, it just mentioned about the gearbox power and the speed range, right, and no other information. We know that only 12 speed gearbox, maximum speed, minimum speed, and each level, no other information. So, how are we going to proceed, right? So, what we have to understand, we know that this is a sliding image, it is a sliding image. The moment we have sliding image, by default we always prefer to use spur gear, yeah, okay. So, the gear type, spur. Do you have any other information? No. What about gear profile? Gear profile, involute profile, it is involute, full depth. How about pressure angle? You can use a standard pressure angle, okay. So, we will choose here 20 degree as a pressure angle. So, these are the standard thing, okay. So, spur gear type, gear profile is the involute full depth profile, the pressure angle we assume as 20 degree, okay. Any other information do we need? Of course, you need to know your basic formula. Though module not given, but we are not going to calculate, but using that we will derive other information. So, the module equation m equal to your pitch diameter by number of teeth, pitch diameter d suffix p is number of teeth z. So, I will use z is the number of teeth, okay. Z is the number of teeth, right. And one more thing is n we use as a speed, RPM. These are the notation we are going to use in the entire course work. How about the center distance? See, in gearbox we always use called a line diagram. See, assuming this is the shaft, okay, this is the shaft, one gear is here, right, we will do like this, is meshing with another gear, right. Then we need to have one more shaft for meshing aspect. So, this would be meshed with the another gear, right. So, the distance between these two shafts is called your center distance A. A is your center distance. In fact, we are going to use center distance method in our calculation. Assume that you have one more gear on the same shaft. This is the smaller one, right, meshing with the bigger one. So, what happened to the center distance here? Would you expect different or same? Should be same, otherwise can't have a transmission. So, that is the reason center distance is a very critical. So, one more information, usually the center distance A is equal to the number of teeth between two gears. You can have a Z1 plus Z2 by 2 into module. Assuming this is gear 1, gear 2 and this is gear 3 and this is gear 4. Okay. So, this is for A1 assuming. So, center distance constant. So, another equation you would expect number of teeth Z3 plus Z4 divided by 2 m. So, if you equate both center distance A, right, and B, we can clearly say that number of teeth, since the module is same, as okay, all the time whenever the two gears are meshing, it must have the same module. Then Z1 plus Z2 must be equal to Z3 and Z4. So, this is the center distance. This is what we are going to use it in our calculations. Okay. And one more information, whenever we do the gearbox aspect, we always start minimum number of teeth. This minimum number of, to avoid interference and undercutting, right? Yeah. So, that should be the teeth minimum less than or greater than or equal to 17. This is the way we have to start minimum thing. So, these are the assumption. Okay. So, as we go on, I will introduce more other parameters, other informations also, right. Let us move on to the solving the problem. So, this is the kinematic diagram. Okay. So, this already we constructed and we have a kinematic diagram of the entire thing. So, in fact, we are going to start with the stage 3. This is supposed to be 3. This is supposed to be 3. Okay. Stage 3, if you look at the gears are meshing, G11 mesh with G12, okay. Then G13 mesh with G14. Which is the smallest gear among these? Is it 13 or 11? Remember, whenever we calculate the number of teeth, we should focus for the drive gears, not the driven gears. Obviously, the drive gear, which is the transmitting power or torque. Okay. So, that is the one, it is creating a stress to the driven one. So, obviously, you have to focus for your driving gears rather driven gears. So, among 11 and 13, 13 is the smallest gear, because the number of teeth also depends on the size, right. So, that is the lowest among the 14 gears in the gearbox. The 13 is the smallest one. Gear 13, I put G, which indicates gear 13 is smallest. It is okay. So, now we know that. Similar also, this should be stage 3. Okay. Yeah. Now, look at this. So, we have stage 3 C, right, moves to B and A. Okay. So, see what is the input speed for C? Input speed is 125 RPM. Am I right? Yeah, it is 125 RPM. Okay. For B, it is a output speed 250 RPM, and A, which again output speed is your 31.5 RPM. Okay, you can see clearly when gear, right. So when you have a C2A, or in terms of we talk about the gear aspect, gear meshing, right, it's a gear 11 meshing with gear 12, right, that's the one will give you the lowest speed. Yeah, okay. So if you again refer to your ray diagram, if you look at this, the gear 11 is meshing with the gear 12 and the gear 13 meshing with gear 14. So if you want to have a lowest speed, the gear 13 meshing with the gear 14 will give you 13.5, right. Gear 13, gear 14, okay. Is it speed reduction or speed up? Speed reduction, yes, correct, speed reduction. Okay. Now we talk about C to B. Its gear number 11 meshes with the gear number 12 is speed up. So you will understand. Now you can see that why we have to use both array as well as kinematic diagram to understand the aspects. Okay, that's fine. Now we can move to the next information. So number of teeth calculation we are going to have a. So as I said, we are going to use a center distance method. That's the one. So I am sure we can start straight away. I have done the trial and error method. You can start as minimum 17, 18, 19. Since I have done that, I will straight away start with the gear number 20. Okay, let use your gear. I am talking about gear 13. Z3 is Z13 should be 20. Yeah, that's there. Okay, so I'm sure you know the formula. Z13 divided by Z14 is a number of teeth inversely proportional to your speed, right. N14 and N13. Tell me what is the speed for N14 and N15. That's what we need to know that. So N14 speed would be, yes, 31.5, right, 31.5 RPM. Your N13 is your 125 RPM. Okay. So when you substitute, I want to understand, because of already I fixed N13, so I need to find out Z14. When you want to find out Z14, right, so Z13 N13 by N14, you substitute the values 20, 125 divided by 31.5. Okay. So I would expect some fractions. So I am getting 79.36 as a Z14. Okay. But looks it's a fraction. Gear is supposed to be a whole number. It cannot have a fraction. So what are we going to do? Right. Either we can round up to 79 or 80. Either round up to 79 or 80. So assuming that we will have a case A. Case A, when you have a rounding up Z14 as a 80, okay, and case B will do both, so that you will understand what is the way to do that. Z14 as a 79. Okay, please understand, earlier we discussed step ratio. The step ratio can have 10% of variation. So that will take care of that. You can ask the question, we have to maintain the step ratio by rounding off, are we not affecting the step, right? Yes, we are, but within the permissible limit, right. 17.6 is just one number, so it's a very fraction, not even a 1%, will be even fraction of 1%. So that's fine, it's acceptable. Okay. So we'll do the case case A, we'll do that based on that. Case A, we assumed Z14 as a 80. Okay. Now what we are going to do, we are going to use the center distance method using center distance method, because the center distance is constant. So you have Z, okay. So you can see that Z13 plus Z14 must be equal to, right, Z11 plus Z12. So this equation you can have a 1. Okay. So now so our known data, what is the known data? We know the only speed, we don't know the number of teeth. Okay. So we have to refer again number of speeds aspect. Your N11 would be what is the speed, and N12, please look at your ray diagram, that will help you, 125 rpm, and this should be 250 rpm. Okay. 125 and 250 rpm. So Z11 and Z12 equal to N12 N11. Okay. So but one more thing, interesting thing is what happened, you are increasing the speed from 125 rpm to 250 rpm, that is already known from the speed if you look at this. So in the second pair of gears. Okay. So then equation, what happened, my center distance equation. So since speed up 125 rpm to 250 rpm in this stage, okay, your Z11 I can assume as a 2 times of Z12, right, Z12, that is assuming as equation number 2. So then substitute, you will have a Z11 plus Z12, right. Now I will use other way around, 13, 14 equal to 11, right, and Z12, and if you rewrite, this is 20 and this is 80. Instead of Z11 I can have 2 times Z12 plus another Z12. Okay. So ultimately I would expect 3 times Z12 must be equal to 100. Okay. So now the Z12 approximately, right, it is come as a 33.33. Either you can take it as a 33 or 34. Okay, that's the thing, 33 or 34. But we know that your Z11 must be 2 times, Z11 must be 2 times Z12. Already you know that the number of teeth of each pair should be equal on the both sides, right. Can we do the quick calculation? So by doing that, if you choose as a 34, right, if you choose as a 34 Z12, okay, if you choose Z12 as a 34, then Z11 should be 2 times of 34, it will be 68. Okay, 68. Yeah. So as aware of that, already in this side your Z13, Z14 must be 20 plus 80, we should expect 100. If you calculate Z11 plus Z12, okay, if you do that, what happened, Z11 would be 34 plus 68. What is the answer you are getting? 102. 102. So, do you think is it correct? Doesn't match, does it? No. Okay. So, they are not equal. They are not equal. Okay. So, because if you choose 34, it is not making any sense. I mean, it is not making any sense. So, what is the way to do that? Right. Okay. Let me choose instead of 34, if I choose Z12 as a 33. What happen if we use a Z12 33? My Z11 would be 2 times 33 is good 66. 66. Okay. But earlier what we have done, so Z11 plus Z12, 33 plus 66 should give 99, but the calculation we got 100, right. If you look at this 100, so they are not equal. So, how are we going to do that? Absolutely correct. So, the case B, right, in the case B what we have assumed that 79, right, because 17, what is that number? 14, right. The 79 we have choose. If we choose Z14 as a 79, right, then Z13 plus Z14 equal to, right, it's is 20 plus 79, right. That should come, right. If you choose your Z11, which is 33 and 66, and that's coming as how much? 99. So, we are satisfied, right. You can clearly see that if you choose Z14, so Z14 as a 79, if you choose Z14 as a 79, then you are able to satisfy the center distance. You are able to satisfy and maintain center distance as a constant for all 4 gears. So, by we can establish Z11 equal to how much? Z11 now Z11 should be 33, your Z12 66, Z13 20 and Z14 as a 79. These are the speed we obtained, right, for stage 3. Okay, stage 3. Now, we will move to stage 2. We will move to stage 2. So, in the stage 2, we are going to have a 3 gears, right. So, the gear is meshing G5 mesh with G6, that is one thing. Okay. Then you have a G7 meshing with G8, gear 8, then G9 meshing with G10. Okay. So, you have 3 pair of gear meshing. Now, we need to know what are the corresponding the speed also. So, if you refer the diagram, the kinematic diagram, so you could see that you are getting 3 speeds, right. F is split into E, right. Next one is D, other one is C. In fact, F speed from F to E, the speed is 500 rpm. Okay. Then you have a F to D to 50 rpm, and F to C is 125 rpm. Okay. 125 rpm, whereas f speed, what is f speed? 355, right? 355. In fact, F to E, what is the corresponding gear meshing? What is the corresponding gear meshing? Right. So in stage number 2, you have to look at your ray diagram also, right? Yeah. So tell me, what is the gears are meshing for F to E? Yes? 7, 8. G7 to G8. Okay. And also look at this, your input speed will be 355 rpm, right? Your input F input 355, okay, and your output, okay, E output, let us do that. E output, what is the rpm? 500 rpm, and D output 250 rpm, and C output as a 125 rpm. So clearly says here the observation would be, we are going to speed up. So it's start 355 to 500. So this is speed up. That's the information we are observing. Okay. Now we are talking about, this is one aspect. Let's move on to the other aspect. F to D. What gears are meshing? From your ray diagram, please. What gear? 5, 6. Gear 5, gear 6, right? So gear 5 and gear 6. So you can see, clearly see, it is 355 to, right? You are going to have a, 1 second, it's supposed to be D, right? 250 rpm, which is speed reduction. Speed reduction. That's observation, we can see that. Now finally we look at F to C. Okay, FCT, what gears are meshing? The gear 9 to gear 10. So the speed would be 355 rpm to 125 rpm. So clearly this is also speed reduction. So from this we can able to clearly understand, when the gear 7 and 8 meshing, you will have a speed up. When gear 5 and 6 meshing, you will have a speed reduction, and gear 9 and 10 meshing, you will you are having another speed reduction. So you will have a 2 reductions, 1 gear up. Okay. Now let's move on to the number of teeth calculations. So already we know that the minimum number of teeth already we found from Z13. So no need to do it again, because earlier all the gears are unknown. So we made one gear as a known, and using center distance method try to find out the number of teeth of each gear, right? So since already we know that information, using that information we are moving to the stage 2 and try to continue for stage 2 gears also for number of teeth. Okay. So here look at the speed reduction. Speed reduction from, we will start from G9 to G10, reduction from G9, okay, to G10, right, which is coming 355 rpm to 125 rpm. That is what is happening. So from here Z9 by Z10, N10 by N9, yeah. whereas N9 is given from your ray diagram 355 rpm, your N10 125 rpm. Okay, clearly given. Yeah, so I think we need to again start. Okay, earlier statement what I gave may not applicable, because of each stage you need to have a assumption again, because that cannot carry. Okay, so now I am assuming my Z9 as a 20. I am assuming Z9 as a 20. Then Z11, sorry, Z9. From Z9 we need to find out Z10. Okay, 355 125 into 20, I would expect 56.8. So if you do approximation, because already right, we know the number of teeth also. So when you do the approximation, Z10 should be equal to 57, and my Z9 is already 20. Okay, that's one thing. Now we will talk about other next one, speed increase, speed up, speed increase from gear 9, sorry, should be gear 7 to gear 8, right, from 355 rpm to 500 rpm, 500 rpm. Okay, that's clearly given. So Z7 divided by Z8, N8, N9, 500 by 355. Yeah. So if you want to identify Z7, right, in terms of Z8 I will keep it just like that, and I know the value that's coming as a 1.408. Okay, and if you refer your center distance, the Z9 plus Z10 must be equal to Z7 plus Z8. Okay, substitute that 20 plus 57, right? Yeah, 57 must be equal to Z8. I can replace Z7 equal to Z8, right? Yeah, 1.408 plus Z8, and if you find out what is that value you are getting, 31.97, approximately 32. Okay, approximately 32. So, and what happened my Z7 then? Z7 it's coming as a 45.06, should be 45. Okay, look at earlier we got Z57 Z10 as a 57 and Z9 as a 20. So my total number of teeth would be 97. So let's cross check. If I do Z8 and Z7, that should come 32 plus 45. What is coming? 70, 77. So does it match now? Is right? It does. So there. Okay. And one more thing. So in the beginning of the this gearbox aspect, particularly machine tool gearbox, what we said, the minimum number of teeth difference between the two adjacent gear must be 4, so that the sliding can be taken without any trouble, okay, without any problem. So if you check the difference between Z7 and Z9, they are getting minimum difference of 4, correct, isn't it? So we know that your Z7 is 45, your then Z9 is at 20, obviously you have big difference. Similarly Z10, Z8, it should go greater than 4. So here also satisfying that. So now we are able to do within the second state for 4 gears. There is one more pair is left now. Okay, the final one. Okay, within the second stage, right. So here you can see the speed reduction is happening. Speed reduction G5 to G6, that is 355 RPM reduced to 250 RPM. Okay, this is already we are able to see that Z5 by Z6 equal to N6 by N5, which is 250 by 355. Okay. So I want to write in terms of, because both are unknown to me, so Zy equal to Z6 into 0.70423. I am taking it as the equation within this equation number 3. And if you refer your center distance aspect, the number of it is Z7 plus Z8 must be equal to Z5 plus 6. You can take it as the equation number 4. So, but we know the speeds also. Your Z7 is 45, right, and Z8 is 32, right. Then this is Z5 plus Z6. But we know the relationship from the equation number 3. If you substitute equation in equation 4, right, so you would expect this is 77, so this is in terms of 76, right, sorry, Z6 will be 1.70423, and finally I would expect my Z6 equal to we'll say equal to 45.18 is approximately, I will take it as a 45, okay, approximately 45. Then the Z5 would be what? 32. So if you look at the summation, the 45 plus 32, it should give me 77. Okay, so that's also satisfying. In fact, if you summarizing, you will have Z5, okay, 32, Z6, how much is coming? 45, right? 45. Then Z7, 45, and Z8, 32, and Z9, 20, and Z10, 57. And if you summate this, if you add these two and these two and these two, will have a same total number of teeth. So which is satisfying, keeping the center distance constant in that second stage. Okay, second. Now we will move on to the this is supposed to be stage 1. Okay, in the stage 1, the final one, gear 1 meshing with gear 2, we can see that, right. Then gear 3 meshing with gear 4. Okay, it's fine. Now again, if you refer to the ray diagram, what is happening? It should be reduction, right, by default. So in stage 2, 1 gear up and 2 reduction. Okay, in stage 3, 1 gear up, 1 reduction, but in stage 1 most of the time should be gear reduction, okay, right. So what is happening? H2 G, right, then H2 F. So from H, what is the input speed for H? 1000 RPM if you refer with your ray diagram. Then what is the output speed for G? Which is 500 RPM. F output speed 355 rpm. Okay. So in fact H2G, can you give me corresponding to gear aspect gear meshing? Gear 1 to 2, right? Gear 1 to 2 is speed reduction. Okay. Then H2F gear 3 meshing with gear 4 is again speed reduction. It's a speed reduction. Yeah. So now we will do the calculation. Right. So speed reduction is happening at two speeds aspect. One is G1, G3 to G4, which is again I am repeating 1000 rpm to 355 rpm. Okay. So if you do the Z3, I will rewrite Z3 Z4 equal to N4 N3. Again we need to assume, let assume the smallest one Z3 as a 20. So if you calculate Z4, you would expect, right, approximately 56. Then next pair speed reduction from gear 1 to gear 2, which is 1000 rpm reduced to 500 rpm. Okay. So Z1 by Z2, N2 by N1, then which obviously double speed reduction by half. So obviously your Z2 should be 2 times of Z1. Okay. If you again follow the what do you call it, center distance aspect, center distance aspect, Z1 plus Z2 equal to Z3 plus Z4. So this one should be 3Z1, straight away I am doing, and this one 20 plus 56, right. So 3Z1 should give me 76 Z1 approximately. Okay, approximately I should choose as a, it's coming around 25.33. Okay, either I can choose as a 25 or 26. So according to number of teeth, you supposed to get how much? Earlier we found out 20, right? 20 for Z3, right? 20 for Z3. Then Z4 is 56. That's what we did it, because we take it as a approximation. So what is your understanding? Do you think that is correct? By choosing Z3 as a 20. Now let's first we'll discuss. This is 25, and you are getting what happened to the Z1 is 25. If assuming that if Z1 is 25, right, Z2 would be 50. Okay, but our total is here is 76, right? 76 is not correct. Okay, if you choose Z1 is equal to 26, Z2 should be 52. So if 26, 52, what happened? It's not matching with the 76. So this is not correct. So what is the way to achieve it? You can change Z1, Z3 as a different value. You can change Z3 as a different value. In fact, if I take Z3 as a 21, right, straight away I will have my Z2 equal to how much? Z3 equal to 21. So, Z4 equal to how much? You should expect 60, right. It is now coming 81. It is coming 81. It is coming 81. So, again you redo the calculation. My 3Z1, right, it should come as a, since, right, 3Z1 is coming as 80, then Z1 I am approximately considering 27. If I do that, my Z2 should come as a 54. Look at this, the new summation 21 plus 60, I should expect 81. Okay. If you recalculating based on this calculation, Z1 is 27 and Z2 is 54, a summation you would expect 81. So, that is matching. That is matching. Please understand that you may ask question, sir, we are talking about center distance, but each case the center distance is different. How is different? The number of teeth are different, that is fine, but as long as you maintain the center distance between the two sets, it is fine. The third set is again is with respect to second state, not the previous one. So, that should be all right. In fact, by summarizing what I want to say that, so assuming that this is my center distance between first and second, I am getting some value A, right. The next one can have even smaller distance or bigger distance also, that is fine, right. So, I can have a one more center distance, which is this is A1 and this is A2, this is third stage. A1, A2 need not be equal, they can be greater or lesser also, that is what you are understanding. So, in fact, if you summarize the number of teeth, Z1 equal to what? Z2, Z3, Z4, okay, Z5, Z6, then Z7, 8, 9, 10, right, 11 and 12. So, what is the value you are getting now? So, one is 27, 54, okay, 27 and 54, then we are getting values please, Z3 and Z4, 21, 2160, Z5 and Z6, 32, 45, yeah, okay, Z7, 8, 45, okay, 32, yeah, 9, 10, 20, 50, okay, and 11, 12, yes, 66, 33, yeah, no, okay, no, something is wrong, right? Is 20, 57 correct? No, should be 99, right? Yeah, 13, 14, yeah, that is what I am feeling. Something I am missing here. 13 and 14. What is the 13? 20. And 14 will be 17. So, yeah. So, you can see that this is one pair, right? And this one and this are one set and this is our one set. If you look at the number of teeth are summation of number of teeth of the meshing gear is satisfying of the each stage. Okay. I think I will stop now. In next class, we are going to do the unconventional structural formula of 14-speed gearbox. Only the ray diagram we are going to discuss. Okay, thank you.